An electric motor is essentially a machine designed to perform work. It takes energy from a wire and converts it into physical force. We judge a motor's value by the usable physical output it produces. The way we rate these machines follows that one specific rule. Look at a standard industrial electric motor sitting on a factory floor. It's a heavy iron workhorse. Bolted to the side of the machine is a metal manufacturer's plaque. Stamped into that plate is a power rating measured in kilowatts or kilowatts. If we are paying for the electricity coming out of the wall, we might expect the motor to be rated on that total draw. Instead, it is defined specifically by that kilowatt value. That kilowatt stamp represents a specific type of power. To see why, we have to follow the electricity as it moves inside the machine. This is a cross-section of a motor. When electricity enters the system, it immediately divides to handle two separate tasks. The first task is creating a magnetic field. Energy flows into the outer coils, generating a strong, invisible magnetic environment. Without this, the machine cannot function. Notice how the center of the motor is completely still. Maintaining that magnetic field requires energy from the grid, but that energy isn't yet spinning the motor shaft. Engineers call this background energy reactive power. Like the bricklayer's sweat, reactive power is the essential effort required for the motor to exist and function, but isn't the final output. The second task for the electricity is forcing the central shaft of the motor to physically turn. This energy, the force creating that physical rotation, is called active power. This rotation is what performs the work. It turns ventilation fans, pumps municipal water through pipes, and drives electric vehicle wheels. Every ounce of that active power is measured in watts or kilowatts. Because the physical rotation is the only part of the process that exits the machine as work, we label the motor by that single output. We ignore the reactive power and rate the machine on its active power in kilowatts. Inside the machine, both powers exist side by side. Reactive power builds the magnetic foundation, while active power creates the physical movement. This distinction is a standard part of professional engineering. Imagine you are sitting in a job interview for a technical position. A hiring manager might ask you, "Why are motors rated in kilowatts?" It is a common question used to test a candidate's grasp of electrical fundamentals. You can now provide a structured, professional response. Let's look at the most effective way to summarize it. Start by stating that a motor's primary job is producing rotational motion, and the energy performing this physical work is called active power. Next, explain that because we use motors specifically for that physical work, we rate them based on their active power, which is measured in kilowatts. You can then clarify that while the active power does the spinning, reactive power is still required to maintain the motor's internal magnetic field. Conclude by noting that since physical rotation is the ultimate objective, the active power metric is what determines the motor's rating. Having that clear breakdown makes the concept easy to communicate. You now have a solid understanding of how these machines are rated and why.